Hi, and welcome to this video where we're going to be showing the workflow between MBS and TEKLA structures. Specifically, what we're going to be showing is how you can take multiple building sections that have been designed and detailed in MBS and then bring them into the TEKLA structures workspace where we can join those buildings together or stitch those buildings together into a single structure. So a couple of notes about MBS. What you want to do is make sure that your buildings are aligned at least to a general location. That's going to make it easier for you to move those building sections together in TEKLA structures. You also want to make sure that things like your roof purlins are spaced correctly so that when they're extended out, they will hit each other to allow us to apply connections. Those things can be modified in TEKLA structures afterwards, but it's going to be a lot easier for us to get that out of the way here. Again, we want to make sure that the buildings are completely designed and detailed, so if we want to pull up one of the default MBS rigid frame drawings, just to kind of show an example of that. Once we're ready for import, you want to make sure that you have a TEKLA structures model open as well. So what I have here is a brand new model created. It is a blank workspace essentially. It is worth noting that you can go ahead and create your own custom setups, starting with a model template that's going to have things like your standard drawing styles and your favorite reports already preloaded for you. This example here, just a basic empty model, but we are ready to go ahead and do the import. So in MBS, what we want to do is go up to the utility dropdown and choose the run slide rule option. What this is going to do is take all of the structural information that we've been designing and detailing in MBS and convert that into a TEKLA structures friendly format. So anything like your profiles or shapes for your structural members, your sheeting and panels, bolts, holes, welds, all of that is going to be converted and imported into your TEKLA structures model. Depending on the size of the project, this could obviously take a few moments. Bigger and more complex buildings are going to take a little bit longer than smaller and simple buildings. So we're just going to go ahead and give this a few moments to complete the import. Okay, so once the export and import is complete, we can go ahead and close MBS so we can continue our work in TEKLA structures. Now we're going to demonstrate how you can use the power of the TEKLA structures model to take the building sections generated by MBS and combine them into a single structure. Once we're in TEKLA structures, we can quickly create views, either manually or based off of the grid system that was generated, simply by right-clicking and creating along every grid line. This now means I have, say, an elevation on grid line 2, so if I wanted to edit some of the framing or even create a drawing, I could do so from here. The display settings in TEKLA allow you to show or hide different types of information. So if I wanted to hide the sheeting, for example, we could filter out those types of objects. We could get a better idea of what's going on with the framing. We can also hide things like different elements for clarity. So if I wanted to turn off welds, for example, I could do that. As we can see, the different building sections that were generated by MBS still need to be aligned into their correct positions. So there are some TEKLA tools that we can use to help us do that. So what I'm going to do is enable a selection filter, essentially filtering for that second area of the building, so that we can grab just the entryway and move it into the position that we want on our main building. So I'm going to flip to a plan view, drag a selection window around that building, and because of the filter I can grab just these specific sections, and then we can go ahead and use a move command to move it into the position we'd like. Now that this building entryway has been moved into position, I can start taking actions like trimming back sheeting, adjusting the framing, and making everything fit together nicely. One of the first things we may want to do is adjust the main structural framing. So again, I'm going to use a visual filter to hide the sheeting temporarily so that I can see the structural members underneath and make our adjustments here. Any objects that we don't need anymore can simply be selected and deleted. If we have objects that are now too long, we can also use a command called split to break them where they're going to be framing into a member now that the buildings have been joined together. Then the remaining piece that we don't need anymore can go ahead and be deleted as well. In this example, we can see that the entry building was designed with some bypass purlins so that we could extend out the roof to meet up with the main building roof. However, what we might be able to do instead of the bypass purlins is simply extend the shorter pieces out until they frame together. Remember that for best results and minimal cleanup, you want to make sure that that entry building has its purlins set up with a spacing so that they align with the main building purlins. So what I would do for a situation like this is make sure that I take care to save the bolts that I'm going to be using. So that would be the bolts here that we see in this connection plate. If bolts are going through multiple members, we just want to make sure that we don't accidentally delete them when we delete the members we don't need anymore. So I'm going to go ahead and adjust these, finish with those 4, and then we can go ahead and delete the piece that we no longer require. And we can use an extend command to stretch this out to now meet the main building purlin. We could simply grab the handle and use a move command, but we do have a series of tools here in our applications and components catalog that can aid with that. So in this case, you can simply select the member you're framing into, then select the member you'd like to extend, and it'll go ahead and extend those out until they hit. For something that is maybe a little bit longer, where we simply want to break it here, we could just use the same type of split command we used down at the eave of the building, simply going to Edit, Split, pick the member that we're wanting to break, pick the location we want to break it at, and here I'll just turn on a snap point so I can grab this leading edge, and then we can delete the piece that is no longer required. So it would just be repeating those commands up through the rest of this roof area, either extending or trimming or doing whatever was necessary for those members, just kind of rinse repeat up the building. Once your main structural members have been either trimmed or extended out to meet their intersection points, you can use the basic steel tools to create any type of connection you want. So by using plates and bolts and welds, you can fashion any type of custom joint anywhere you like. However, TEKLA does have an extensive joint catalog here in the Applications and Components pane. There are several hundred included out of the box for different industries. There are also more available for download from our warehouse website. But some examples can be seen just by searching for the word bent to bring up some bent plate components. In this case, I'm going to use a joint 151 for the main purlin to purlin connections. Simply by double-clicking on the dialog box, we can make adjustments to the configuration, sizes of material, bolt spacings, and more. So I can load in a setting here, go ahead and apply this between two members, and we can see how TEKLA Structures goes and creates the joint for us. Once you have customized that to look the way you want, you can just continue by picking the remaining locations where this joint is going to be desired. For another example, we can use a different bent plate component. This is joint number 190 to connect my eave material together. So here I can set up or save a specific setting for a left side joint. And then on the opposite side, we can use a right side joint. The idea being is that as you develop these connections to behave the way you like and have the bolt spacings and whatnot, how you like to do them, you can save those properties away to very quickly load and apply those and then reuse. So here's another example of some overlapping framing where we have these two columns on top of each other from joining the entry building to the main building. Now, just like we've already taken a look at, I could use a split command to break this here, but I want to show you something else. We could open up an elevation view. Let's actually do that based on the grid system like we mentioned at the beginning. we can actually see a little bit more clearly how this is kind of sitting right on top of the other building column. So what I'm going to do here is a command called direct modification. Direct modification is kind of our push and pull, drag and drop method, where I'm going to tell this that I only want to move it in the Z direction and then simply drag this handle upwards. And you can see hopefully there that the column is getting shorter. So I'm going to zoom in a little bit closer and take it right up to the top of this plate right here. So that's just another way. Again, I could have used edit split to shorten that member. Now, this cap plate on the main building column is no longer required to extend out this far. It's no longer supporting an eave member. So we'll just go ahead and delete out that extra plate. And we could use direct modification here. We can either drag and drop is one method, or we can simply highlight that end handle and use a move command. So this is, again, one more method that we have to adjust the size and shape of members. So now that that column has been shortened, let's go back to our main 3D view. I'm going to turn on a clip plane so we can actually see this a little bit better in 3D. And there we can just verify that the column has been shortened. Now we could go back to our steel tab, model in by plate, by bolt, by weld, a connection plate here. But instead I'm going to go back to the component catalog and try to find something that'll work. You can do a search. I'm going to do a search for the word base, and I happen to know that there is a base plate number 71, which is meant specifically for situations like this when I have steel posting up off of steel. I do have a preset that I've already created that essentially sets a plate size, sets a bolt configuration for me. So if I go in here, I'll be able to pick the cap plate, pick on that post, and now you can see how there's a plate created there with bolts and welds and everything we need to fabricate that member. Now for parts that we don't have an existing member, like we've been taking a lot of looks at these extending, trimming, direct modifying to push-pull members. If we need to create something new, I could double-click on an existing piece here, use its properties, and then the beam tool to actually draw a fresh one. But if I want to match the orientation and the position and the height value, sometimes it's easier just to copy an existing member. So I'll select these, run the copy command through the right-click menu, and then simply kind of move or copy-paste using the handles those members over to the side. So now that I have these here, there's a couple of options I have, again, using split, using the direct modification to pull the handles back. But one more thing that we can do is actually use direct modification in conjunction with these dimensions that you see when I highlight a member. If I zoom in here a little bit, let's try to position this so I can see this better. I can see that this member is currently 2411.5 long. I can click on that text, choose which end I want to adjust, and then say what I want this total length to be. So I'll make this 9'6.5", and I can see how that's pulled back now roughly to the center of that column. I could probably make a little bit more adjustment to that. I'll do the same thing for this upper member, clicking on the text, clicking on the arrow indicating which end I want to move, and then again typing in the dimension 9'6.5" to shorten that member. So one more way to manipulate these pieces, and again I could use a connection here. We'll do a search for some of these purlin joints that I have, and again load a preset. It's going to set up a plate size and a bolt configuration for me to connect these pieces together. There are also some tools in the component catalog that can help with creating roof purlins or girts. In this example, I can show the generation of purlins component, where you can define your spacings, your setbacks or overlaps from each other, the profiles that you'd like to use, and orientation. And then this works pretty simply by picking kind of a start point. Where do we want to measure from? and then what pieces we want these to frame to. So in this case, I'm just picking the flange plates and then this wide flange column at the end. And when I middle mouse click, it'll go ahead and create those very quickly for me with the breaks at each intermediate member at whatever spacing I've defined. So just one more nice tool to be able to very quickly recreate some framing or set up new framing from the original MBS buildings. I'm jumping into another model for a moment because we want to take a look at some new connections that have been developed by the US Steel team to help with when you have to stitch together buildings made out of 3-plate that are going to be coming together at odd angles or just some more complicated geometry. These are going to be available on the TEKLA warehouse for download. So the first ones I want to take a look at are the beam to beam and beam to column options that we see here. I put together just a couple of framing conditions so we can see how these work. First, taking a look at the beam to beam option. We have two provided here, one that's going to create a plate between the two members. If I go ahead and pick these two, you can see that it's going to create a full depth shear plate with bolts and copes. If I go ahead and open up this component, we can see that we've got a lot of options in here, things like the position which side of the plate is going to be on, whether we want to have a full depth shear tab or a partial shear tab. You can control the sizes of the plates and cuts, the sizes and locations of the bolts. So a ton of controls in here in order to set up this connection exactly how you would like to see it done. Also, there's going to be a bent plate connection. So if I go ahead and insert this, again, we can control things like, do we want a plate on one side? Do we want to have plates on both sides? The radius, the connection style, whether this is going to be bolted or welded. Also, there's a really nice list of options for different ways that these folded plates can be created that'll meet your needs and how your shop likes to work. So once you have all these configured, again, you can just pick the webs of the main members here, and in this case I've created a bent plate that's going to be bolted all the way around. So those two are going to be really nice for these beam to beam situations that you're going to see. Again, we're going to have some for beam to column situation. If I go ahead and use the beam to column bent plate option, I'm going to go ahead and load a preset that I've created here for a single-sided plate that's bolted. Just like the beam to beam, we can go ahead and pick on the basically the main parts that we're trying to connect together, in this case the flange and the web. And like before, we can see that the plates created, bolts are created, copes are created if you need them, and all of these things are adjustable. And just like we showed before, not only is there a bent plate option, but we've gone and created a beam to column shear plate option. So if I go ahead and pick these two, we can see it's gone ahead and created some cuts. I could turn those off. Plate created, bolts, and this one is going to be welded to the column web, as we can see here. Just like the beam to beam option, if I open up the properties, we can adjust all kinds of stuff about the setbacks, cope sizes, plate shapes and configurations, bolt styles. So tons and tons of options for being able to customize this exactly how you like to see things done. The other connection that I'd like to show you, let me rotate around here so we can look at this other building that I've created in the back, where we have some purlins that are bearing on some wide flange beams. Is this flange brace tool. Now, the import from MBS is going to include these flange braces, but if you need to create some that are bent in the field, just other custom types, this is a nice tool to have in your back pocket. This is going to have, again, a ton of options for connecting these types of members together. In this case, we're creating a plate that's bolted to the purlin so that the angle brace has something to connect to. But if I go ahead and open up the options here, you'll see that there are a ton of drop-down options for how this is going to be connected, whether we want this bolted directly to the purlin, whether you want to have this bent in one direction or another to connect to the the web of the beam or to the flange of the beam. So again, just a ton of options that you can adjust here to set this connection up exactly how you like it to be. And then once you do have an option chosen, let me go ahead and go back to that little stiffener plate that we have down here. We can go ahead and reuse those as many times as you need to on these different purlins. In this case, you can see I'm just sweeping the members so that the connections get applied to all of them at once. So now that we've taken a look at those, let's go ahead and jump back into the main building model that we imported from MBS. The TEKLA structures model can also be used for helping with our sheeting layouts, getting all the accurate lengths needed. Let me go ahead and turn those back on visually so that we can see that the ones that are still here are the original length of the two designed sections in MBS. So we need to shorten those, cut them back to the actual lengths we're going to need to provide to the job site. In order to do this, we can use some workplane tools in TEKLA to basically save away the roof planes that we need to work in. There's a couple of workplane tools that allow me to do that. One of those simply by clicking, it's literally a tool called the workplane tool. That also can be saved. So if I call this the main roof front, now this is a workplane I can go back to if I need to switch to the model origin or back again to this. I can do so pretty quickly. Another workplane tool might be something like this using 3 points, which you might use for more complicated framing. And in this one, I'll just use some pick points on a rib of this deck to lay out the workplane for the entryway. So again, I'll come in here and save this way, call this entry left. And now I've got that workplane saved away in here as well. So once we've set up those work planes, I might actually jump back to the original model origin here and re-hide those sheets, because I want to set up a work line along this valley here between the two roofs, and then set up essentially where my sheeting will stop with a nice 6-inch setback from that valley line. So for that, we can use some basic modeling tools like construction lines. Construction lines are here under the construction object section, and as you can see, there's lines and planes, circles and arcs and more. In this case, I'm just going to go from this point here, basically if I were to project that eave member over to meet this one, and then we will throw this construction line down where this purlin would have met the roof purlin. So a slight adjustment there because I already had a connection. If I did not have a connection yet, it might be a little bit easier to find that point. And now I can offset this 6 inches in each direction, but I'm going to do it based on those work planes. So first I'm going to do it for the main roof front. We'll go ahead and use the copy with offset option here, and I want this to be offset 6 inches. So we'll click on that and then hover along this top flange, and then I'll change this to the entry left, pick on this again, and then hover over an edge for where we want to copy this in that particular direction. So if I look closely at this, and I'm going to try to rotate this so we can see easier, we're kind of creating the offset up each side of that valley. So I hope that becomes a little bit more clear of what I'm trying to lay out here. So if I'm ready to go ahead and start trimming some of that sheeting back, what I'm going to do is create a view at this entry left, since that's my current work plane that I have set, so that I have a nice flat view to work in. Sometimes it's just easier to see things that way. So I'm going to create a custom plan view called the entry left roof plane. And I'm going to now create a new view based on the current work plane. So now I'm actually looking at this entry building roof section as if I were looking straight down at it. And as you can see, we're looking at the other building, the main building, as if we were kind of looking at it from an angle because of that. So it may seem a little cluttered in here, so what I may want to do is hide some of these sheet objects from the main building. Let's see if we can do that through a filter here. So I want to do the template MBS building does not equal main. And let's see if that one works for us. There we go. So now I can see just the entry building sheeting here along with the construction lines. So what I can then do is start trimming these back to whatever lengths I need. So if I wanted to cut this out to the longest point, again, I could use the split command like we've been talking about. So I can go to edit split, choose the sheet I want to cut, choose the point that's critical for me. Let me go ahead and turn on some snaps here so I can grab that point, and then go ahead and delete the section that's no longer required. And we would just continue up this path. You don't even have to delete them right away. Let's split that one there, split this one here, and I could just keep repeating this command over and over again. Let's go ahead and delete those out so we can kind of see what we've accomplished so far. And then if I go ahead and turn all the sheeting back on, we're getting kind of a better idea on what is actually going to be provided, those actual lengths for those sheeting members. So whatever you do on one view or one plane, we can go ahead and do on the other plane. So I'm going to set my work plane to the main roof front. Again, I'm going to go ahead and create a new view, but this one is going to be the main front roof plane. We'll go ahead and we'll create a view based on this work plane. So now I'm looking down at the main building as if it were flat. Again, we can see our construction lines. Again, in order to clarify things, maybe what I might do here is say MBS building does not equal entry. There we go. So now I can see where the main roof sheeting comes down and can be again trimmed back if we wanted to. So I'm going to go up and use my split command, and we'll split this there at the longest point. And again, we'll just kind of repeat this for a few of these sheets just so that we can get an idea on what this process would look like. So I'll do one more, and then let's go ahead and delete the scrap that we no longer need. And again, we are now breaking this down into the actual true lengths that we're going to be submitting and shipping to the job site. If you'd like to go ahead and just create new sheeting, these members can either be modeled in using the beam tool, or we have tools like this floor layout that can allow you to create large areas of sheeting very quickly. In this case, I'm going to load some settings that I've already got preloaded, including the shape being used, the name, and things like material grade. And then it's just a matter of going through and picking on the perimeter of the area you're trying to fill. So in this example, I have the other half of this roof section kind of removed. Now I can just go ahead and trace the area that I'm trying to cover, and that creates a sheeting group quite easily. This tool, while not applicable to this particular project, has the ability to make adjustments to this sheeting, things like changing the direction. So if I grab this arrow and drag it horizontal, you can see how the sheeting actually changes direction. Now, of course, I wouldn't do it that way. We can also go ahead and add things. Let me go ahead and set this back again. We can go ahead and add things like openings. So if you do have an opening that you need to block out to provide some type of access through the sheeting, and this tool, by the way, works not just on roof but also on walls and vertical surfaces as well. So just another powerful tool in the toolbox to help speed up some of the modeling you might need to do. Once your modeling is complete, you're ready to start creating drawings. All drawings in TEKLA come from the model, whether it's a plan view that's been turned into a view on a sheet, or whether it's an assembly or a shop drawing that comes from a model object. One of the first things you want to do is you want to update your piece marks through a process called numbering. This is not required before you make an erection drawing or a sheet layout, but it's always good to have that in place, so that way your piece marks don't need to be updated later. So I'll go ahead and I'm going to number my model, and once that is complete, I'm ready to make a drawing of this. All plan drawings or general arrangement drawings come directly from the current model view. So this model view, looking in 3D, I might want to flip this to a plan view to go ahead and make a sheeting layout. I'm then going to right click in the background and say create general arrangement drawing, and in here we can set up drawing properties for what we want this sheet to look like. The same types of filters that you use in the model views can be used in drawing views. There's also different settings for piece marks and dimensioning styles and all kinds of stuff. There are going to be some out-of-the-box settings that we can choose from. I've got one already loaded here called roof sheeting. So that's simply going to filter out all my structural objects and leave the roof sheeting behind. And then I can go ahead and say, let's open this drawing right away. You'll also note that I could include multiple model views on one drawing at a time, but I can also cut sections and add them later. So I'll go ahead and hit create. And as you can see, now I have a sheet created with a sheeting layout with piece marks, also a table including all of the pieces and their quantities with their current marks. You can customize the title block. You can create new templates if you wish to include different types of tables. But as we can see, this is a pretty complete drawing here. Now, if for some reason you did want to cut a section, I'm going to go ahead and reuse the section view properties from the main view. We can go ahead and do that at any time simply by picking 2 points, and then you can define a range of how much you want to see. The magenta box that you see is the definition of that range, and it too can be changed after the fact. So I'm going to go ahead and click, and then finally I'm going to place this view off to the side. So at any time, as you can see, very quickly you could make new views, cutting them around the model. And normally you would do this for more of a structural style plan. But these drawing properties, as everything else, are very customizable to how you want your drawings to look and the types of things that you want to show. For another example, we'll show an elevation drawing of a rigid frame. Like I mentioned before, these are going to come from model views, so we can go ahead and open a view, say the elevation along grid line 2. This dashed box is the current work area. We can go ahead and adjust that to include the areas of the building that we actually want to show on the drawing. And then again, we can go ahead and right click in the background and say create general arrangement drawing. In here, it's showing the current selected view. Again, I'm only going to choose to create one view per sheet. Just like before, we have a setting. This one is called MBS rigid frame. Go ahead and click the open drawing checkbox and hit create. Just like before, what happens is TEKLA goes ahead and creates a sheet of paper for us, places that model view on the sheet of paper, and as you can see, we get a pretty decent drawing layout from that. We have some tables that are included, like we can see a title block, we have a bolt table and a member table. Just like anything else, these are customizable if you want to add to them or change them out. You do notice that it's pretty minimalistic. There's no dimensions being created, pretty minimalistic when it comes to marks. And you can go through and add a lot of that stuff yourself through dimensioning tools on the dimensioning tab. Annotations tab is going to include things like texts and symbols. But what we've done in partnership with MBS is we've created a small application that will run some routines to automate a lot of that. When you go ahead and download it from the TEKLA warehouse, it'll be found here in your applications and components under the ungrouped items. Specifically, I'm going to run the rigid frame dimensioning tool, but you can see there are other types for different types of drawings as well. So I'm going to go ahead and run this, and this is going to open up this dialog, which includes some different settings that are already preset to work with a lot of the default stuff you're going to be running. These can be changed out for how you like to create your models, but I'm going to go ahead and hit apply. And then what this tool is going to do is scan through the drawing. It's going to find those views and find those objects and simply run a series of routines to automate things like dimensioning placement, mark placement, and other things that I could totally do myself. This is just going to provide a very fast way to get there. I do notice that there is this one dimension that is a little bit wide because it's trying to dimension out to the widest grid point that was created by that entry building being imported. It's a pretty easy fix though. You just go ahead and grab that end handle on that dimension and simply drag it back to snap to the grid that you can see. And that's really all there is to it. And like I said, you can do further cleanup on this sheet, but this is going to give you a really good starting point for getting your drawings done. Next, we can take a look at creating fabrication drawings. Like I mentioned before, you need to make sure that your numbering or your piece marks are up to date. So if you haven't done that, you want to go ahead and run it. I'm going to go ahead and hide the sheeting from our view so that we can actually see the objects a little bit better that we want to create. So now I could do this. I'm going to show on a case-by-case basis creating one drawing, but there are selection filters down here at the bottom of our screen that we can use to select all of the purlins or all of the rafters or all of the columns. So what I'm showing is just one at a time, but the same process basically applies. So what we'd want to do is go up here to our Create Drawings. And here is a list of all of the drawing styles that are already preloaded. And as you can see, I've got a beam option, and a brace option, and a column option, and so on. So first I'm just going to go in and grab one of these purlins, and we will find a purlin with BOM option, and then come up here and click Create Drawings. So just like the plan drawings, what's happening here is we're having views being created and placed on a sheet of paper, but rather than it being a view that I'm determining, it's basing the created views off of the actual objects. So let me go ahead and open this up, and here we can see that dimensions are created, bill of materials are filled out. In this case, the hole diameters are being marked. One nice thing to note about TEKLA drawings is that you don't have to worry about changing any type of scale or messing with any type of settings when it comes to the dimensioning. If for some reason you wanted to add more dimensions, not that they're necessarily required on this sheet, you can just come in here and pick your 2 points, and as you can see, the dimensions are intelligent. They know how far that is. So you're never going to be editing text or fudging the dimensions that you see here. They will simply match what you have in the model. Now take a look at some other drawing types. I've gone ahead and set up a column and a rafter drawing setting here. The reason I set these up, especially away from the other drawing settings, is that due to the 3-plate design, the drawings tend to be a little bit over-dimensioned. So I like to create them basically with minimal dimensions so that I can go ahead and clean them up as I see fit. So we'll do one for the rafter, and then I'll go ahead and come down here and do one for this column. And again, you can create filters to do batch members, lots of columns, lots of rafters at once if you want to. So now in my drawing list, I have a rafter drawing and a column drawing. And as you can see here, I've got it set up again with minimal dimensions. That way I can add exactly what I want rather than having too many on this sheet. And as I also mentioned before, it's very easy to come in here and just add your dimension strings. You do not have to worry about editing this text or somehow manipulating or fudging things. You simply come in here and start adding your points that you're trying to dimension to, and those values will simply be what they are. So that makes it very easy to add any type of cleanup to a sheet. There's also many different dimensioning styles that are available. If you wanted to change this to, for example, be a running dimension where you have tails so that someone can run a tape, you could do that instead of the string. We could also do something like a combined dimension where you have the string and the tail numbers. So there's a lot of different options in here, and of course you can adjust the colors and fonts and arrowhead types and all that good stuff. The column drawing that I created is going to be very similar. When I come in here and take a look at it, you can see minimal dimensions so that I can go ahead and add what I find to be the critical information for my shop. But once again, bill of materials are filled out. We do offer 5 different styles of bill of materials and title blocks out of the box, so if you want to use one of those, that's great, but we also include the tools that you can customize those templates. Things like section cuts can also be enabled in the drawing settings to show up automatically, but you may find that with some drawing types, TEKLA almost creates too many sections, or perhaps creates them in a location that you don't want to see them. So sometimes I prefer to go ahead and just create my own. And just like we showed you on the plan drawings, you can activate a section cut property. In this case, I'm going to use sect cut. And then you just come in here, you pick on 2 points to indicate a cutting plane. And then you define a range for how much you want to see in that view. Finally, place where you want the new view to be created, and then this view can be dimensioned and annotated in any way that you like. The command can simply be reactivated to add more section cuts. So if, for example, I wanted to add one here on the base, looking up, we can go ahead and just repeat those same steps to eventually get as many section cuts as we want on this sheet. Single part drawings are also going to be very similar to that process. In this case, I'm going to go ahead and use a filter to maybe go ahead and grab some of these plates a little bit easier. So I've just grabbed a handful of them here on top of this column, and I'll go back to my create drawings, and in this case I'm going to switch to the single part drawing settings. And again, there's going to be bent plate and channel and brace options, but for just the individual pieces, the ones that are not welded together. So in this case, I'm going to use the plate with BOM. Go ahead and hit Create Drawings. And then go to my drawing list or document manager. And now I have a lot of these W type. These are workshop drawings or single part drawings. And if we go ahead and take a look at them, again, you can see that things are dimensioned out. Title blocks created, and one nice thing about our single part drawings is it's automatically going to list out for you how many of these are required on each assembly. So that's just great for the shop to be able to track, you know, what's being fabricated and what's being placed where. Now if I wanted to do something like create CNC files for these objects, that's also very easy to do. So if you have a plasma cutter or a plate burner, you can go ahead and highlight these objects, go up to your file menu, choose export, and then NC files. The NC files can be created for profiles, plates, or angles. They're just different settings so that we get a little better results for those different object types. I'm just going to check the plates option and then hit create. And that quickly we've created the CNC files for those objects. So if that is a need for your shop to be able to generate those NC files, we can also convert these to DXFs if you need to run those in that format. So anything that you need to be able to cut this steel, we can generate it for you out of TEKLA. The same is true for any bent or folded plate. There are drawing settings available that will automatically go ahead and unfold those for us flat. Also, any CNC files that you would make of these plates are unfolded flat for fabrication purposes. Just to give you a look at what those single part drawings look like for these guys. As you can see, we get dimensions not only to the plate and the hole locations, but also to the bend line along with the angle of the bend. So very helpful for the shop to go ahead and fabricate these plates. In addition to things like drawings, from the TEKLA Structures model, we can generate all kinds of reports and shippers. There are two main methods for generating this data out of TEKLA. Under the Drawings and Reports menu, you have a Reports option. There are a bunch of out-of-the-box reports in here. We also include a tool called the Template Editor that allows you to customize or create new reports to match any type of style that you may want. There's another tool called the Organizer. What the Organizer does is it actually scans through the model, collects all of the parts that are here, to provide a what you see is what you get output that is organized based on certain properties. This could be things like the name, this could be things like the material grade or piece marks. We do have an MBS shipping list to generate your shippers, and they have already been pre-configured to search the model based on things like name. So as you can see, we have a column and rafters, purlins and girts, sheeting, and so on. As you click on each group, what you're going to get is an instant feedback report in a spreadsheet style layout. Each of these has been customized to give you a pretty good output out of the box. And of course, just like anything else, these can be customized further to fit your needs. Once you select one of these styles, you can do things like grouping. We can group based on a size and shape simply by dragging the column header up to this upper section. So now I'm grouping by profile. If I X out of here, I can also group based on things like the description or name. So you get a lot of flexibility here for what you want to show. Once you have this organized the way you want, we can go ahead and export these as Excel spreadsheets using templates that we can customize. If I go ahead and hit export, what this is going to do is take the current list of data as we see it and send it out to an Excel file. But there is now all of the data in Excel, so we can go ahead and we can save this away as multiple files. You can go ahead and group these into different tabs, however you want to get this listed out. Each of these can be run independently, so you can choose exactly what you want to generate at any given time. Again, you would just go ahead and hit export. This creates the Excel file, and then you can save it and do any further work that you'd like to do to clean these up. The organizer can also be utilized as a type of selection tool. If you choose a category, like for example this purlins and girts, and then right click and choose select in the model, it'll actually go and highlight those because the categories are based on a similar property. So it serves as a nice way to be able to select a specific object for things like maybe creating drawings, or if I wanted to run a report. Like for example here I have a punch report that I would want to run from the purlins. I can now create that from the selected objects from the organizer to create that report very easily. Okay. So I hope this helps give you a good overview on the workflows between MBS and TEKLA structures, some of the capabilities of TEKLA structures once you're here, and some of the customizations that you can do. If you have any questions, you can always reach out to us, and we appreciate you taking the time today to watch this video.